My name is Brooks Patrick. I work on the 3D team here at Esri's California office. Today's topic is all about procedural modeling and its role in 3D urban planning and design. 3D is at the heart of an essential strategy for managing and planning a city. To help articulate this, we've invited two guests that can show you some really incredible work. Now, allow me to step back and really frame the focus of today's webinar. To do this, I'd really like to start by sharing with you some of my experiences when traveling the world presenting Esri's 3D solutions. I've recognized three main recurring themes all over the world, from Beijing to Riverside, California. First and foremost of these common recurring themes is the onset of global urbanization trends. 4 years ago was a very special time for cities. It marked the first time ever that cities were representing over 50% of the world's population. Because we're in the midst of rapid urbanization, cities are going to be built fast. It's my hope that we're able to correct many of the mistakes that were made in the last 30 years. As China and India builds its cities, it can't just take the recipe from 20th century America and apply it to 21st century China or 21st century India. That would be horrible for them and horrible for all of us. Second are the pressing environmental challenges that are facing cities today, the eventualities of natural and man-made disasters. In fact, the parallels between man-made systems such as the economy or the electricity grid and complex natural ones are bringing new ideas to strategic planning and risk management. This trend will have profound implications for policymakers and planning organizations alike. Resilient communities really begin with location awareness. And finally, third is that meeting these demands are expected to be fast and efficient. What will our cities look like in 10, 20, or even 40 years' time? Today we are going to be discussing Esri CityEngine software. CityEngine supports the rapid design and implementation of new planning capabilities and climate resiliency strategies. At the same time, improving the methods of communication towards accessible, real-time 3D solutions. So 3D drives better informed decisions by communicating ideas more effectively, by in essence telling a story. You'll of course draw your own conclusions, but today we will go over some examples and features to bring Esri CityEngine's procedural modeling to your organization. So during this webinar, we will be featuring a series of quick polls. I'm going to go ahead and launch one, and when the time comes, an interactive question will appear, giving you the ability to submit your answer. We'll go ahead and tally the numbers in real time and share those results back with you. So go ahead and answer your first question. Have you ever modeled a 3D city by yourself? Okay, so thank you for answering. I'm going to go ahead and close that. We have an overwhelming 64% that say no. And I assume that's because you haven't been using a procedural modeling software yet. But to give you a better idea of how this stuff works, I'd like to first introduce our speaker today, our first speaker today, coming to us from Gothenburg, Sweden. So Arvid is a 3D visualization artist for the City of Gothenburg, responsible for visualization, virtual reality, and other CityEngine procedural modeling operations. Arvid is also an industry leader in 3D modeling and graphics and visualization and has worked with film, advertising, and game production. Today he will be presenting an example from Gothenburg's Center City, the Free Harbor waterfront project, a pretty big deal in Gothenburg and most of Sweden. It's really an amazing case of 3D urban design and comprehensive planning, along with all of the other amazing work they're doing. Over to you, Arvid.
Thank you for the introduction, Brooks. Hi, everyone. I'm Arvid Forsberg, 3D visualization artist within Gothenburg Planning Agency. Gothenburg is the second largest city in Sweden, with just over 500,000 residents, and it's located on the west coast of the southern part of the Swedish peninsula. Historically, Gothenburg was an industrial city, with many of the industrial sites still existing today throughout the inner city. As one of the major Swedish ports, we see much of the waterfront taken up by these large docks, many of which are decommissioned as the port moved closer to the sea and out of the city. Today, our downtown is growing, people are moving back, the downtown population is on the rise, buildings are being renovated, and new urban projects within Gothenburg's different districts are bringing back renewed energy to the city. With this being said, there are huge challenges ahead. The city needed the ability to plan more efficiently and improve the public interface with many of the major projects underway. Many of them actually involving these industrial sites that I mentioned earlier. CityEngine proved to be a great tool to meet these challenges. Because of the immense impact and 3D nature of inner city planning projects, we felt that we needed a way to be able to communicate these changes with stakeholders, decision makers, and the public. Another main factor in our decision to pursue a new 3D model for the city was its unifying effect, i.e. the ability to use it to coordinate city planning projects between departments internally. We also have many different softwares, both CAD and GIS, being used in planning processes across the city. CityEngine really gave us a platform for bringing this work together, supporting all of these different formats. Our main goal was first to build an existing conditions model of Gothenburg, then use CityEngine's procedural modeling to quickly model all future plans for the city, starting with the Free Harbor project in order to review the entire unified vision. And finally, we wanted to be able to share these models internally with different stakeholders and externally to help with public engagement. Early in its adoption here, we experimented using the Free Harbor project as a pilot. And I'll quickly explain our workflow here using CityEngine's procedural modeling. We first import our GIS street data, and CityEngine enables modeling networks and lots with parametric rules. These rules have parameters, or commands, and we need to control what type of model is generated. With rules on the streets and on the lots, a procedural 3D city model is generated, with only your imagination setting the limits of what is actually possible to generate. The rules also enables us to consider and create different real-time reports with vital information during the planning process, like FAR, floor area ratio, or the predicted number of occupants. First, because of the direct compatibility with GIS, we're able to import all of the networks that make up the roads and pathways in Gothenburg. These are typically represented as a single line in GIS, and some additional information telling us how wide it is, etc. CityEngine actually models out the street and the sidewalks from that single network line. And then we applied one of the example street rules to these shapes. This extruded sidewalks, scattered objects like street lights, and also textured the street. A nice feature inside of CityEngine is the ability to create blocks when these street networks are completely encircled. We are then able to subdivide these blocks and create lots. This subdivision type here, with buildings next to the streets and inner yards, is very, very common in Gothenburg. And after this, we can apply rules to the subdivided lots to generate buildings, like you see here. With the resulting generated form, it was then important to further refine the parametric rules. Design questions arose like, which attributes would we, the city planners, the city architects, want to be able to alter, and what type of reporting most matters to planners while modeling and building masses? On this slide, you can see our first simple city model, featuring randomized bottom floor colors, floor numbers, and roof types. All of these randomized attributes could, of course, be set manually, so we could, for instance, change roof color on certain buildings. And here's a quick slide showing our first version of the Free Harbor GIS street data, which we imported into CityEngine. We then used the data within the network segments to allow CityEngine to model out this as streets. Then, together with city architects, we started changing the width of all these streets to match our current design iteration. And this network you see here was done by myself and just one city architect during one morning meeting. This slide shows one of our first visualizations from spring of 2013, showing the volume and scale of the Free Harbor site at, say, the year 2035. With it, we better understand the relationship between hierarchy of transportation networks and the land use across the project sites. We further compared view sheds and waterfront interface, both very important components in urban design. For me, the value of this interactive 3D map became clear during our first meetings with the city architects. The 3D model gave us a shared view and understanding of the different project spaces and their context within the larger plan for the city. The 3D parametric modeling became a powerful tool, much as the 2D section drawing was used traditionally, giving us an understanding of the relationship between the urban corridors and the built land use surrounding. And on this slide, you see one of the many street section styles we used in the beginning of the Free Harbor project. With a project zoomed to each project site, we could virtually place ourselves in the environment that we were depicting in these 2D sections. And this is a really powerful feature and often used to create images and animations for our city planners and architects. A common zoning constraint is floor area ratio, meaning that the mass of a structure can be no more than the mass of a one-story structure covering the entire parcel. Parking and aesthetic requirements limit this type of building, so alternative designs must be evaluated against FAR ratio constraints. Just a simple CGA rule outputs an FAR score for instant feedback on a design's viability. On this slide, we see we had exported the large avenue streets from CityEngine and straight into a physical-based rendering system without changing anything, just to quickly create daylight simulations. And this slide also shows the next iteration of our model. And together with the programmer Sandra Stendahl from Sweco, which is a large Swedish architectural and urban design firm, we further designed the architectural styles that could be represented. And Sandra was able to translate these styles into CityEngine CGA code, which make up the parametric rules used to model these facades here. We wanted more details on the buildings using the facade style variations. And some of the designs you see here are based on recently built lots here in Gothenburg. Our CityEngine model has many different levels of detail, also known as LOD or LOD. And this one was to become our highest LOD. And this detail is not to replace the necessity of architects, of course. This type of facade modeling merely allows for more flexible work with the building interface. For example, the number of balconies. Are the balconies recessed or extrude? How do these smaller details affect the appearance within the larger context of the site? It also shows the scale and the number of generated floors from afar in a more pleasing way. And no other tool really allowed us to experiment at this level of detail at such a large scale, at the city scale before. These early models convey in a clear and understandable way how the city is looking to grow, both in density and in form. And as we continue to use this technology in our planning practice, we are looking for new ways to leverage CGA scripting to support the evolving planning process. And our group now has iterative weekly meetings with the city architects and planners. Traditionally, when a planner or developer looks to build in the city, they create a static rendering or sometimes a video or an animation. We were able to provide them not only the 3D content from our internal charrette, but also an updated web scene to take away. The CityEngine web scene is an online resource using WebGL, where users can explore the city model in real time in a web browser. They use it for planning, meetings, and for creating pictures for presentations. With that being said, we could provide them the entire 3D model. But the procedural modeling is very efficient in generating 3D environments to the point that it would and will overload most other 3D softwares. Just this Free Harbor site alone, and the model you see here, was 80 million polygons of optimized geometry. Just to give you a sense of scale and size, the 3D model of the Godzilla movie back in the late 90s, which still is my favorite reference, was about 1 million polygons. And this means that the Free Harbor site would be about 80 Godzillas. Next slide, please. There we go. So this geometry, featuring our highest level of detail, was of course impossible to import into real-time visualization systems and into 3D engines, and also of course into softwares that the city planners and architects were using, such as SketchUp. We essentially had to split up the entire high-res model even further into smaller quadrants for the city planners and architects to take with them. These models would, however, be old by next week, until the next meeting, that is. But these parametric rules allowed us to keep the entire city model up to date in real time. And to visualize this heavy scene, we used Maya and the Arnold renderer. Our next goal, which was a big one, was to create a 3D printed physical model of Gothenburg using this CityEngine project. It was initially built for the MIPIM real estate show in Cannes, France, 2014, but this model has visited multiple expos since then, and it just came back from Munich, Germany, and it actually travels more than I do. And creating this physical model was a huge undertaking. It meant importing all of our roof data for this area of Gothenburg and generating three-dimensional buildings for this. And it also meant generating a large and heavy terrace-like ground model suitable for 3D printing. And these enormous tasks were given to and delivered by my colleague, Tobias Wikström. And to make a long story short, after a few months of hard work, the 2x2 meter model was finally complete. The red and green parts here were created with CityEngine, and the larger white areas were generated from our GIS data of Gothenburg. It was built modular for transport purposes, and here's a work in progress shot before all the 64 tiles were generated and delivered. The heaviest tile weighed around 3 kilograms or 6 pounds. And as we produce our second, third, and fourth edition, next time perhaps we will print the terrace or print the terrain separate to the buildings. This would allow us to better switch out the new updates to the plan. Another common output for our CityEngine model is the Urban Explorer table, where city planners and architects often gather and have meetings and discuss plans and concepts. It's an interactive real-time visualization system and perhaps the most used end product for our CityEngine model. Our main place for public outreach in Gothenburg is the River Room, or Älvrummet in Swedish. Here we have a 12-meter wooden model of the city showing new projects, and also other interactive touchscreen products featuring our CityEngine models. There's also Visual Arena, our visualization center in Lindholmen, and this 6-meter screen often present our city models. And in the image on the right, you can see our most recent CityEngine demonstration for a delegation from Shanghai visiting Gothenburg. We refer to our in-house production pipeline as virtual city planning. In summary, this enables our department to visualize and present city projects in an easy way, present complicated projects in a non-complicated way, create decision support material for politicians, easily test planning concepts in real time during meetings, quickly identify problems and stop impossible scenarios, and create models which have multiple end products. We also use this pipeline when we're planning the big Gothenburg 400-year anniversary in 2021, where our CityEngine model will be used for multiple products. In closing, what we found is that virtual city planning leads to a common view of the projects, shorter, more efficient meetings, better communication and coordination between departments, and that it's easier and more intuitive to communicate city planning to the public. And what's next, you might ask? Our current model is just the tip of the iceberg, and we're actually dreaming on what we might see there underneath the surface. We're currently working hard on the version 2 of our city model, which will premiere at the next BIM Expo in March of 2015. This next generation city will spawn at least 3 more physical models in the near future. And lastly, we hope that you can come and visit us here in Gothenburg to see our work. And I thank you very much for your time. And I have included my email in case you have any questions about what I have presented here today. I'd be happy to discuss this work further. Thanks.
Thanks a lot, Arvid. That's really some amazing work. Before moving on, we'd really like to know your thoughts. So I'm going to launch one more of these quick polls. Did this last example resonate with you? Take a moment to answer. Yeah, overwhelming yes. Really amazing work coming from Gothenburg in Sweden. Really a new way of planning a city.
Thank you.
So let's go ahead and dive into a couple more great examples from around the world using CityEngine. During this year's Esri user conference, the Urban Redevelopment Authority of Singapore demonstrated how CityEngine software has become a crucial urban planning tool for one of the most densely populated countries in the world. They recognize the future comprehensive plan will be data hungry. So how do we start to visualize this data? But furthermore, how do we start to work with this data, format environmental economic constraints, right? You can see here that the URA was able to implement CityEngine rule-driven modeling within their planned constraints, like this lakeside view shed. The buildings are able to adapt on the fly, enabling a flexible 3D design environment. Another great example comes to us from Rochester, New York. The city's goal was to achieve a shared and common 3D view of their city that they could use to support their planning process. This is a really great example using CityEngine for comprehensive planning and to support the development review process. The city worked closely with Esri's partner Bergman Associates to implement their 3D vision. Rather than show you a PowerPoint slide, I'll actually open up one of their web scenes. So this is the web interface that Arvid was referring to that the City of Gothenburg is using as well. The City of Rochester is actually overlaying their master plan design, their 2D master plan, on the terrain of that city. So we can actually dip in here, and I'll go ahead and turn on the 3D content. So this really gives a very effective way of projecting the 3D model on the wall without the need for a high-powered desktop at some of these planning and stakeholder meetings. Very rapidly, you could bring someone to a specific location within the city and really have a conversation about that location. As I mentioned, they overlaid that master plan, which represents the future growth for the City of Rochester. Using one of these CityEngine rules, they were actually able to use the footprints and generate buildings based on their form-based code within the city, looking at height, looking at the different glass interfaces of the buildings. You can also do comparison. So all of these layers can be set up within the CityEngine project ahead of time, and you can actually have a swipe between the before and after. Very powerful tool. Really liberates 3D modeling from the desktop computer like never before. Moving now over to the California coast, nearby me. We can find a great example coming to us from nearby San Francisco. The Bay Area Rapid Transit, or BART, was looking for a way to communicate transit-oriented development plans both internally and out to the public. BART also recognized the efficiency and impact that can be achieved by communicating their plans in 3D. BART is working with Esri Professional Services to define their 3D modeling process using the Richmond station as a prototype. This project laid the groundwork for how BART is going to move forward with modeling all 44 of their stations in 3D to better communicate the development plans for the areas surrounding each station. Our second speaker today is coming to us from Garsdale Design Limited, located in the UK. Matt is an architect by training, and I should mention, before Garsdale Design, he worked for Esri R&D Center in Zurich, where CityEngine is developed and got its start. Over to you, Matt.
Thanks, Brooks. Thanks a lot. I hope everybody can hear me. So yeah, hi, I'm Matt Bueller. I'm currently the head of 3D technology here at the UK-based Garsdale Design. My background is in architecture, but since after university I'm getting more and more specialized in 3D graphics and visualization. Having worked in the CityEngine development team in Zurich before made me one of the very few CityEngine specialists worldwide. My specialty is high-end graphics and digital sets, and I hope we here at Garsdale Design will soon also provide services for the VFX industry. Today I'm giving a brief overview over the most interesting key points of the Favela project I did in CityEngine with my friend Cyril as a hobby project. In a minute we'll have a look at a few of the images we produced, and if you have not seen the video yet, just search YouTube for the keywords CityEngine and Favela. In this first picture we see an exterior view of the Favela model, which was then used for the actual project in an interior scene. The project is a digital reconstruction of a Brazilian favela. For this we created the village in CityEngine and then brought it over to Maya for rendering with Maxwell Render. This all sounds easy, but it was not. I had the inspiration for the project about 3 years ago when I saw a 3D rendering of a favela that was entered in an online rendering competition. After having studied all the details, I knew I could do better than that, and I asked my friend if he wanted to join me for the project. The main goal was to combine all the knowledge I had gathered up to that point working in the CityEngine dev team in one big project. The other goal was to create the biggest and most complex CityEngine project ever done so far, outside of Hollywood movie productions like Cars 2 or the more recent Total Recall or Man of Steel. In this first interior rendering, we see that the CityEngine model was scaled down to the scale of 1 to 500 and actually used in this fictional hobby room where some imaginary hobbyists are working on the favela as a physical model. Some details even indicate that the physical model is not yet even completely finished. So for example, on the tray in the foreground there's some of the prepared buildings that are still missing in the bald corner of the model on the left side. All interior elements of the hobby room were manually modeled by Cyril and myself in Cinema 4D and Maya. The scene was then assembled in Maya for the final renders. Some of the elements, like for example the pictures on the walls or table, are work-in-progress pictures that we had collected over the course of the project. So for us the whole project really is also a reflection on the saying, the path is the goal. The final complete interior scene allowed us to render many interesting views, like for example this one, where we get a very clear idea about the model scale, but also note that, for example, all vegetation leaves are rendered with thin poly subsurface scattering, which gives it a very realistic volumetric appearance. Just as a note, all the vegetation used in the project, which is about 12 species, were also created procedurally within CGA. Another view, this time more close up. Putting the camera this close to the buildings allowed to view all the details we had added, ranging from realistically scattered vegetation to electric poles, cabling and all the rest. Of course, in reality a favela has much more details, but for this scenario of a hobbyist model it worked really well. This extreme close-up rendering sells the scale of the miniature model very well, using strongly emphasized depth of field. And this also demonstrates the extraordinary capabilities of Maxwell Render. So where did I start? Of course, with tests about floors and mass distribution in CityEngine. As we've seen in Arvid's presentation, CityEngine is a procedural modeling application. The definition of how a building is modeled is done in CGA, CityEngine's proprietary scripting language. Some of the first tests I did was to find the best approach to model building volumes that look feasible for the given scenario. This image shows a very early volumetric study. White volumes have a flat bottom side, while black ones have a sloped bottom side. This picture here shows some of the final building volumes. As one can notice, the building volumes are very irregular, with dents and shifting relative to each other. There's even some missing walls, exactly as in a real favela. Next topic, facades. We collected 60 facade images and processed them each in CityEngine's Facade Wizard. The result was a structured library of facade rules that can adapt to all possible given facade geometries that were given by the mass model we've just seen before. I manually post-processed each rule to minimize texture repetition and further marked specific polygons as either opaque wall or window to be able to distribute more objects like pipes and ACs on the facades. In the right picture, we see an example of such scatter regions. In this specific case, for wall elements and potential cable connection points. On another very important part of the project was the creation of feasible roof structures and a realistic distribution of roof furniture. Here we see two work-in-progress test renders that also already featured some dirt detail distribution. I wrote rules that create multiple different roof types, for example some that are still under construction. Some other rules were created to distribute the countless different roof assets that were manually modeled by Cyril, to create a realistic illusion of an inhabited village. Since no favela is convincing without cables or clotheslines, but cables can sadly not really be created procedurally in CGA, I created a Python script that does this for me. By using CityEngine's reporting functionality, I can collect all potential cable connection points, evaluate them, compute the catenary curves, and finally create the cable geometries. The result is quite convincing, where cables go from building to building and connect to the next suitable power line pole. Last but not least, I want to quickly explain the pipeline I had designed to go from the model in CityEngine with a simplified material representation to save resources to start the render in final quality in Maya in less than 1 minute. At least for small bits of the favela, of course, this was needed to be done in under a minute, so we could have a fast design iterations with full artistic control over the project without having to worry about the quality or the amount of details we created for the final model. Developing this pipeline took me about 2/3 of my whole project time, but it also taught me most. So this is the chart of the pipeline, so let's quickly explain it. Working in CityEngine and wanting to start renderings in Maxwell Render from within Maya, I had to bring over two types of data from CityEngine: the model geometry and the reported point locations for each of the plant species. The file format I settled with to export the models to was OBJ, since it proved to be the most flexible. It's a text-based format which allowed me to parse the whole file with code and restructure the data, and that's what I did. Using CityEngine's Python scripting, I exported a series of OBJ files, which usually was around 15 files for a full export. I did not want to export bigger files or file chunks than 1 gigabyte, so I could still open the text file in a standard text editor for checking. Then, using native Python, I parsed this OBJ series and separated out every mesh for every single material into a separate OBJ file. In a full export, that was about 700 OBJs for 700 materials, for which I then used PyMaxwell to create the final Maxwell render materials that could be used in Maya. The final materials included more textures like specularity maps and normal maps, and as also other interpreted metadata that was embedded in each material name. All the steps done in Python, and PyMaxwell were consecutively called from within CityEngine. This means that all of these data post-processing steps were completely automated. A full export with data post-processing took about 3 to 4 hours. On the Maya side, I developed a Mel script that loaded all geometries and replaced the standard materials with the final Maxwell render materials, ready to render in final quality by the click of one button. To bring over the vegetation instancing data, I used CityEngine's console to directly print out Mel code, which, when copy and pasted and ran in Maya, created a separate particle system for each plant species and filled them with the appropriate particle positions. So this was it for the Favela project, and just to have a quick overview what we do here at Garsdale Design Limited. So basically we have an older branch, or the traditional branch of business, which includes architectural, planning, urban design and heritage services. And especially in urban design we have about 35 years of experience in the company. In the new branch that we are now basically exploring, we have a series of new services which include procedural city modeling, that is obviously using CityEngine. We provide high-end visualizations, the creation of digital landscapes. We also provide custom code development, that means CGA or Python. And we have different options for training. So one of the formats we have is 3D Pathfinder, or also bespoke trainings, depending on special needs. So if you have a project that you would like to realize with CityEngine, but you don't have the expertise yet and need training, or would like to outsource that work, just feel free to contact us. And please also follow me on Twitter under the handle @mattb3d. Well, thanks for the attention, and back to Brooks.
Thanks a lot, Matt. So that's really some nice work. Before moving on, we would like to hear from our attendees. So I'll go ahead and launch one more quick poll. Have you ever used a procedural modeling software before? Okay, we got about 50-50 with yes and no. So great, some people with some procedural experience out there. So the big question is efficiency critical to your 3D pipeline? When you compare Esri's procedural 3D to traditional modeling in 3ds or SketchUp, you can see that if many iterations are needed, it's much more efficient to use a rule-based parametric modeling software, particularly with large models requiring high details. With traditional 3D modeling, it's pretty much equal output to equal input. And ultimately, it's about saving costs. And to do some of the work we've seen here today, you might need a fairly large team working in 3ds or SketchUp to accomplish some of the same tasks. In summary, procedural modeling can be explained in 3 steps. First, to bring in your geometry, either GIS or CAD. When using GIS, we can actually take full advantage of the shape data or attributes to further automate the modeling. Then you apply a rule. This is the combination of existing 3D models, like all of the AC units and pipes that Matt was showing, and textures, together with a simple scripted framework called CGA. CGA actually stands for Computer-Generated Architecture. These resulting generated models can get iteratively more complex, from really a basic form to something that better resembles the Parthenon in complexity. These rules make it possible and easy to describe an urban environment by using a set of density and performance metrics. These metrics can be used both to describe as well as prescribe different urban interventions. This is really what sets CityEngine apart from other parametric tools like Grasshopper or Houdini. CityEngine offers a flexible 3D design environment supporting many industry standard 2D and 3D formats on both import and export. CityEngine also provides multiple views of the same data. So you can take these new buildings and change the 3D view from the rendered look to a theme showing building use by floor or even rainwater infiltration rates in blue across the entire 3D model. This really enables different actors in the design and planning process to relate different programmatic demands to different spatial solutions. So allow me to take you now inside of CityEngine and show you how easy it is to create a design proposal and leverage some of these multiple views. Also, I should mention that what I will show you is now available to download along with some essential skills video tutorials on our YouTube channel. That would be youtube.com/CityEngineTV. And I just really wanted to make that point before jumping right into CityEngine. So let me go ahead and take you to any town, anywhere. CityEngine allows us to bring in existing city GIS data, like tree points and street networks that you see here, and completely model the city as it exists in 3D. Highly realistic building models can also be brought in from Revit as IFC or OBJ, or from a vendor like Pictometry. We can use the parameters within the rules to make proposals like how this street might look with bike lanes, etc. In most other applications, you might just have a snapshot, a pretty picture of the model. But we can actually take all kinds of useful information like zoning and land use regulations out of 2D and drape them onto the 3D city model. Many of you might have seen zoning signs, for instance, that notify the public of a new zone change or a new business. And the first question is, what's the current zoning of the property? Plus, what's the zoning around it? So we can see this property here is zoned for administrative use. And we can easily propose a zone change. So we can actually change this to commercial use and even change the maximum floor height. So using these procedural rules. And it's really not only about zoning changes. It's also about evaluating the current city's conditions. So we can actually if we navigate over here to the downtown bank building, we can see if there's an exception or a violation. This building's height has obviously exceeded its zone height, but knowing it's the tallest building in the city, they probably had an exception. So let's go ahead and take a look at one particular project here using CityEngine. In this case, we're interested in the redevelopment of this mall. A major economic challenge facing many towns, at least here in America. And we can start to experiment and experience what it could become. So what could this look like? Let's go ahead and redesign it. The first thing we'll want to do is go ahead and turn off the mall. I've already put it on a separate layer. And using the street creation tools, actually continue Main Street through the site. And you can see as I draw a new street, it's actually inheriting the style of the street I drew from. We'll go ahead and add one more street. And we'll go ahead and delete this segment to leave room for a park. So we can then import CAD or GIS or even draw our development plans right here using the sketching tools in CityEngine. Once we bring in that data, we apply a rule and then actually generate the 3D content. So let's go ahead and dip in here. We can really gauge the design within the larger context of the city to better experience how it looks and feels here. And like I was saying, CityEngine provides multiple views of the same data. So I can go ahead and select these buildings here and change the 3D view from the rendered look to a theme that shows usage by floor. And I can actually strip away all the textures as well. So we can actually further refine our design. Let's add a couple more floors. We'll bump it up to 6 floors. So we can actually add these floors, and it's not just in the model. We're actually getting real-time reports as well that Arvid had mentioned. So what the rule is actually doing is as we change parameters, it's actually reporting out different metrics. Some example consumption variables here, which are based on a baseline and a coefficient based on the land use, but also the FAR, the floor area ratio, or the gross floor area that Arvid was referring to. So it's real-time feedback as you model. So let's go ahead and suggest some tree plantings on this street. It's a little bare. We can actually manipulate the sidewalks here, make them a little bit larger. And using a parameter for the street, we can actually put the tree percentage at 100%. And we're actually using some models for our trees. Let's actually zoom over here to the park. As we navigate over to the park, you'll notice the very realistic trees that we have here. This park actually represents most of our tree library, so you get a pretty good idea of how many trees we can work with. So these trees came from a partner of ours, Eon Software. We worked with them to create this initial library of genus and species specific plants. These trees can be scattered on polygons, distributed on points, like you see here. And they also have 3 different representations. So let's go ahead and select these trees in the park. And much like the buildings, we can actually just switch the view of these trees to something like an analytical view, which in the GIS analysis world is great for communicating the tree canopy and running a shadow analysis on. So I really encourage all of our attendees today to really try out this example, among others, with a free 30-day trial of CityEngine. So we've talked about some of the major themes around procedural modeling and 3D GIS. I now want to focus in on how 3D is integrated into the actual product, supporting the enterprise, connecting multiple communities across this platform. The Esri platform supports BIM, and there are 3 main methods for integrating this highly detailed data into your project. First, direct import from Revit models into CityEngine via Collada or OBJ. These can be rendered with applied textures through a rule. Second, the data interoperability extension to ArcGIS, our core GIS platform here at Esri. This allows the import of IFC formats into GeoDatabase, where it can then be imported into CityEngine. And finally, the FME plugin for Revit, which allows you to configure and export only what you need, that's very important, directly to a GeoDatabase on export from Revit. CityEngine rules can also be shared as a rule package, or RPK, for use within Esri's core ArcGIS software, but also in Unity and Maya with our CityEngine SDK. So these RPKs basically package up the 3D models, textures, and script for sharing. To learn a little bit more about that CityEngine SDK, just visit our GitHub location. The SDK is out there to enable third-party applications and to better integrate within custom pipelines. So for all of the Unity users out there attending today, there's actually a great example plugin available which allows you to actually add the plugin as a component. Then you browse for your rule, and you actually have those attributes that can be changed, those parameters, that can be altered right in Unity, and you hit generate. We really see this type of close integration as really the golden key for 3D workflows in the future. And just imagine designing within real-time environments, really virtually placing yourself on ground level, even navigating inside the building, for instance. With new advances in technology, there are new advances in expectations. As game engine technology gains adoption and advances in real time allow for faster and faster rendering, we really have to keep in mind the technology that is also working hard to increase the polygon count and the detail that is ultimately attainable in 3D. So how is this detail ultimately going to be served? Allow me a minute to discuss Esri's vision for the future of 3D. With our software, we can effectively make more out of 3D than a simple visual. We've seen some powerful work done in CityEngine, giving us fast, powerful tools that support your current workflows and really transform the way you model in 3D. We're bringing this same modeling power to Esri's latest addition to the desktop GIS series, ArcGIS Pro. However, there's also a demand to make 3D work more available across web browsers in the form of web scenes and mobile devices through 3D-enabled applications, and then full circle back into desktop applications. So next year, look forward to these new 3D services that will enable really the next generation of app development. In the past, creating a 3D cityscape was an expensive and manual process. Probably the reason why most of you guys answered no on that poll earlier. And as a city grows and changes, these hand-built models are quickly out of date. We see that clients will come to expect real-time 3D feedback, really this loop, 3D modeling to support a charrette-style design process. We can now rapidly accelerate the modeling process altogether and make use of 3D content like never before. It really comes down to having an overall strategy for bringing the features of CityEngine, like you've seen here today, to your organization's pipeline. This really happens in 3 distinct steps. Step 1 is to secure a pilot, evaluate the data you have. Second, building this into a manageable, shareable 3D city model, base scene. And finally, it's important to have a clear use case in mind. This isn't just about seeing in 3D. This is GIS, 3D GIS. It's about understanding. And once these parametric rules are created, it's possible to further leverage them within many different projects, really streamlining your 3D pipeline. So with that being said, I'd like to take a moment and hear once again from our attendees. Let me launch one more quick poll. So do you have to model a 3D city soon? Take a moment to respond. I'm sure you can see how procedural modeling gives you a number of different ways to further leverage content in this regard. All right, thanks. We do have 30% of us saying, yes, you will have to model a 3D city soon. So with that, I'd really like to hand it over for questions. Use the question box here, or send us a tweet, hashtag CityEngine. Feel free to also email me. Email all of our speakers today.
Great, thank you very much, guys. That was a fantastic presentation. Maybe while we as everybody types in their questions here, maybe I'll have one on my end here. How much training is needed to work with a software like CityEngine?
Arvid, would you like to take that one?
I can only reply from my own perspective. It's a plus if you have previous experience with other 3D softwares. Then it's quite easy to to learn if you know the 3D basics. Otherwise, it's like learning any software. It's easy to learn, but it takes a long time to master it. Like the scenes you saw from Matt here, for instance.
Yeah, and I guess I should mention as well that there is existing training as well. So we have a few different resources available. Other than our YouTube channel, there's actually the ArcGIS Resource Center for CityEngine, which has a lot of different example projects, and also Esri training resources. We just recently released a series of new essential skills tutorials that I recommend checking out on our YouTube channel, CityEngine TV. These are free. They come with a project that I actually demoed for you guys today to really help you get started building the first 3D city model. If you would also like to have a hard copy of that training material, just go ahead and email me. We typically give these out during workshops in hard copies, so please feel free to contact me. My email's on this slide.
Looks like there's a number of questions coming in there. If you want to grab a couple of them, I don't know if we'll be able to grab all of them during the Q&A here, but if we don't get to your question now, then we'll definitely follow up with you after the webinar.
Yeah, I think what we could do is collect the questions in the end and then answer them all one by one if possible, right?
Yeah, for sure.
So I can via email afterwards.
Yeah, absolutely. If we don't get to you, we'll email after. There's a question here about the system configuration required to run this type of software. And then I should say there's a minimum requirement of 8 gigabytes of RAM and a pretty good video card from NVIDIA. But it really depends on how large your project is. The larger your hardware, the better hardware you have, the larger the project can actually be that is generated. The project that I had open demoing to you was about 20 million polygons, and I'm running on a pretty powerful desktop, so it's going to run pretty smooth. But there are ways to actually write these rules that give you different views of the model, like I was showing with the vegetation, that allow for low polygon, low level of detail, and then allow you to switch it onto a higher level of detail upon export. So I guess what kind of hardware are you running on, Matt, over there at Garsdale?
I invested in a quite strong machine, so I have a hex core core i7 machine with actually 64 gigabytes of RAM. So, but since I like to do overkill renderings, that's just what I wanted to go. And but I was for the Favela project, I was actually glad I had that much RAM, or I could have used even more RAM, because it's at some point when editing some of the models, Maya used up to 60 gigabytes of RAM. But yeah, that's all a little bit extreme, and I also have quite a strong gamer level graphics card. But I would say on average for an average user, to have a decent CPU and 16 gigabytes of RAM will be more than or good enough. Let's put it like this.
Great. Yeah, and I see another question here. Is it possible to export CityEngine data into Rhino? And that being said, you can export to many different formats, including OBJ, Collada, FBX. On import as well, you can import OBJ and Collada into CityEngine. These models can be inserted and positioned manually, or I recommend using KML or multi-patch format, which is within the geodatabase. To preserve the real-world coordinates. You can actually drag and drop a geodatabase into the viewport and just pick which features you want to bring in. Otherwise, it's possible to incorporate existing models into the CityEngine rule framework, like you saw with Matthias's Favela example, being able to scatter these existing models. The trees, for example, in my demo were actually pre-made models. Each representation was pre-made ahead of time. So it's really interoperable with many different formats. I also see a question here. What platforms support the current WebGL web scenes? Actually, the big three are supported. Android, Windows, and just recently, as of about a month ago, iOS now supports WebGL. So the size of the current web scene will still matter. If you're trying to run a large web scene on a small iPhone, it probably won't work very well. But with the upcoming release of the 3D scene services that I had touched on, we really envision the same performance and capability you see with our 2D maps at Esri coming to 3D on all devices. So we'll look forward to that. So we're about out of time today. Like we said, we'll definitely email you guys some answers, get in touch. I'm going to go ahead and launch one more quick poll, just whether or not you'd like to be contacted by an Esri expert. So just take a moment to discuss a project, to answer any further questions. So just let us know. All right. Thank you very much for joining us.
Thank you guys. Again, fantastic webinar. And for everybody that inquired, there will be a recording of this webinar put online on the YouTube channel that we'll send to everybody tomorrow. You get an automated email from us with that link.
Yeah, and I'd really like to personally thank our two guests here, Arvid and Matt, for taking part in telling some amazing real-world stories here. We really hope you've enjoyed today's topic as much as we have. So
thank you. It was our pleasure.
Thank you. Thanks for the invitation.